October 17th, 2024 marks the 75th year of the commencement of the Snowy Mountains Hydro Scheme. I'm Paul Michael Angus, a mechanical and civil engineer in Australia's water sector. Come with me as I explore the timeline, the components, and the challenges faced throughout its construction, as well as celebrate the amazing elements of this engineering wonder. We start back again at 1954, and the Guthicka project is well underway and coming to a close as per the previous episode. William Hudson and the Snowy team are still working tirelessly to construct and bring online further storages and hydroelectric facilities to further show the Australian public and their elected politicians that positive progress continues and that their investment will yield returns. Focus is now largely turned away from the Snowy Murray development, however, towards the Snowy Timit development, in which Lake Yuconbean, formerly known as Lake Adamitabie, throughout its construction, will serve as the central storage in the overall scheme. Initial blasts from October 17, 1949, had begun work on the Yuconbean dam site to further explore its suitability. However, the initial plans evolved early on to relocate the final dam site downstream from those shown in the proposed plans handed to Hudson and his team. It's from here that we continue on their journey. The Yuconbean dam site, shown here, will be the final agreed location some 7 kilometres approximately downstream on the Yuconbean River from the initial proposed location in earlier plans. The earth-filled dam works would be underway as of 1956, and filling of the reservoir would take place in advance of the dam itself reaching its final crest height in 1958. For water to leave the lake and enter the Snowy Timit system, an outlet portal and control structure were built on the Tollbar Inlet, approximately 6 kilometres north of the dam site. This structure would serve both as an outlet and inlet to Lake Yuconbean, with a nominal second outlet portal and control structure being provided downstream for its connection with Timit Pond Dam. The reason the Tollbar Inlet structure serves as both an inlet and outlet structure is due to junction shaft being located 3/4 along the Yuconbean Timit tunnel alignment. This intermediate intake is at a much higher elevation than both Timit Pond and Lake Yuconbean, permitting reverse flows to occur. Junction shaft and its cylindrical control gate is coupled with Happy Jack's Dam, which holds back the Timit River in its upper reaches. Without this intermediate intake, high seasonal flows would likely cause Timit Pond downstream to overflow via its spillway, and water available for long-term storage would be lost through uncontrolled flow through the lower scheme. 1 year after commencing construction of Yuconbean Dam, Timit Pond Dam's construction would take place in 1955. This dam would impound the Timit River below Happy Jack's Dam and create the storage which would feed the first power station within the Snowy Timit scheme, Timit 1. Timit Pond Dam would be a concrete arch dam similar in nature to that of Hoover Dam, but to only a fraction of the scale. And like all other storages, require a diversion tunnel be driven through the right side abutment to permit construction to commence. Further upstream of this diversion tunnel, works would also start on driving the outlet tunnel and building the control structure from the Timit Pond storage towards the Timit 1 power station below ground, some 2.5 kilometres downstream under the mountain range. Work on the dam itself would progress over 4 years, block by block, growing it upwards to its final height of 86 metres. The cable transport system would ferry everything from workers, concrete, and even large plant equipment such as this bulldozer across the valley. The image begins to show the scale of the dam and the associated works. By late 1958, Timid Pond Dam was in a position to hold its opening ceremony, and the outlet gates were closed to enable filling to begin whilst minor works were finished. Here, Prime Minister Robert Menzies pulls a lever to close the outlet gates and commence storage operations. The finished dam not only holds back the Timit River, but serves as a key access road between the townships of Cambramurra and Cancoban to the south. The dam itself is a visual marvel and impressive to visit when travelling through the Snowy Mountains, with the outlet structure observable for the dam wall and spillway gates with an easy walking distance of parking at the site. As water leaves the Timit Pond Dam via the outlet portal and control structure, it enters the Timit 1 power station, shown here in diagramical form. Early works had commenced prior to 1955 with an investigational tunnel being driven into the mountain range to understand geological conditions and support its design development. The remoteness of the site meant gaining access presented numerous challenges, but the contractors worked innovatively to overcome problems as they took place. This design plan of Timit 1 provides a visual for the interior of the facility, with 4 80-megawatt generators installed. It turned out that after initial excavation into the machine hall began, ground conditions were not favourable, and a decision was made to extend the machine hall a further 30 metres into Happy Valley granite, which was more sound, as can be seen in this diagram. Vertical pressure shafts were used due to them requiring the least excavation and material for lining, and a surge tank arrangement was provided upstream of control gates leading into the vertical shafts. 3 shafts were driven, 2 to serve as pressure pipelines, the third to serve as a ventilation and lift access shaft. In the unlikely event of Timit 1 flooding due to the Timit River backflowing via the tail water tunnel, the upper region of this ventilation shaft can be used for emergency purposes, as indicated in this hand-drawn diagram. Timit 1 being an underground power station meant that supporting the roof would be the highest priority during early construction. A reinforced concrete rib arrangement was installed shortly after excavation permitted. I understand rock bolting was also used to aid this supporting system, and rock bolting as part of the scheme was greatly pioneered and evolved to suit the conditions. With the roof structure stable, blasting and excavation of the material occupying the space the turbines and generator systems was progressed, along with the inlet and outlet connections to the pressure tunnel and draft tubes leading to the tailwater tunnel. As seen here, the scale of the equipment and structures was epic, and T1's construction, along with its tunnels, would take 4 years to conclude. The scale of most structures within the Snowy scheme are large, to say the least. Here a Land Rover is visible within T1's lower tailrace surge chamber, and another adjacent and access at it in a separate tunnel system. Water entering T1 from Timit Pond Dam eventually daylights again after its approximate 4-kilometre journey from Timit Pond Dam through the Timit 1 power station. This path shortens its former journey by some 8 kilometres approximately, and ends up at the outlet structure, which you can see here is fitted with stop logs to ensure that sufficient back pressure is made available to the turbines due to the fluctuations of the Timit River under its natural flow. So now we've covered approximately the first 9 years of the scheme's construction, with elements of the Upper Snowy development, i.e. Guthaga, being commissioned alongside the early beginnings of the Upper Timit development, now well underway. By 1959, both Guthaga and the Timit 1 power stations would contribute approximately 380 megawatts of generation capacity to the New South Wales and Canberra electrical networks, further showing the Australian public and their elected politicians that progress was taking place at a considerable speed against their investment. Naturally, though, much more work was still to come, with ongoing efforts still being put into the remaining components of the Upper Tumut development, i.e. the Tumut 2 Power Station and Dam, Tuma Dam and Tantangra Dam, alongside the Trans-Mountain tunnels and control systems, which would interlink them all, needing to yet be completed. We'll cover these in the next episode, looking at the overlapping years between 1958 and 1962, where a further 280 megawatts of generation capacity would be brought into use across the Snowy scheme, raising the scheme's total to approximately 660 megawatts. Thank you once again for watching, and please look out for the next episode in this series, exploring and celebrating the Snowy scheme and its 75th anniversary.